Good morning, everyone, and welcome to Ironside's Take 30 with the Data Advisor in our new day and time. Today, we're going to be talking about Netezza, how it's back in the cloud in the form of Netezza Performance Server. So I'm here. My name is Jeff Spear. I run the information management practice at Ironside, and with me is Nira Valia, who's an engagement lead on my team.
Well,
so we're going to have a little bit of background about Ironside. We're going to talk about IBM Cloud Pak for Data, which we talked about a few weeks back, just provide a quick summary, and then go into Netezza Performance Server, which is part of IBM Cloud Pak for Data. Talk about Netezza capabilities in general for those who might be less familiar with it, compare it with some other cloud data warehousing options, and then take questions. As always, there's a question panel. You can submit your questions, and we'll be happy to answer them. So, for this sort of third season of Take 30, we've shifted to having sessions every Thursday at 10 a.m. and alternating between data advisors, BI experts, and data scientists. So today we're doing Netezza. We've got another one next week, which is going to be talking about our modern cloud analytic framework and building a data community. We are also doing that series Tuesdays at 10 a.m. for the next few weeks. So on next week, it's going to be the same session on both days, just to sort of make sure people catch up with the schedule change. And then you can see on the right, we're moving on to some other sessions on other topics. At Ironside, our purpose is to help you use data to make better decisions about your business. We've been doing it for over 20 years. We have a variety of capabilities, all the way from strategic advisory, design, including UX and design sprints, building and deploying data warehouses, cloud data warehousing, visualizations, predictive modeling, a wide variety of things, master data management and governance, as well as managed services and hosting to help you run the platforms that you need. Netezza and Netezza Performance Server sort of usually fall into more the build deploy side of things. You know, it is a data warehouse appliance that lets you construct ETL, ELT, and data warehouses. But then also managed services, because we have several clients for whom we either host their Netezza box directly or we manage it so that they don't have to worry about keeping it up and running, and that's something that we're happy to do for you as well. We partner with a wide variety of technologies and partners, including IBM, who we're talking about mostly today, but we do work with others as well, including Snowflake, which is a competing database product, and AWS, which of course has Redshift. So I want to talk quickly about Cloud Pak for Data. Again, if you want more information, we did, I think it was in week 6, we did a detailed Take 30 on this, and you can certainly go into more detail on it if you have questions, you want to contact us. Cloud Pak for Data is a platform for data analysis, integration, and analytics. It helps you quickly discover, manage, and deploy new insights. And it's a web-based, self-contained tool that has the full analytic lifecycle. You can create a data catalog, you can create governance, you can do data integration, you can do modeling, you can do visualizations, all in one place. And so it's a great way to sort of keep that, if you need people to do that quickly, it's a great place for them to do it easily with sort of all the functionality in one place. But it also can be extended with a variety of IBM and other services. So you can add extensions to it, and Netezza Performance Server, which we're talking about today, is one of those extensions. Cloud Pak for Data is built on OpenShift, which is IBM's platform for both private and cloud deployment. It's built on top of a containerization solution called Kubernetes. The previous Cloud Pak goes into a lot more detail on what Kubernetes and containerization are. I just want to say here, this sort of demonstrates how OpenShift provides an abstraction between the hardware or the VMs or the EC nodes or whatever it is that you're running on and the software itself. And so basically, software that runs on OpenShift, you can sort of, if you have an OpenShift set of nodes anywhere, you can put the software on it and it will run, and it sort of runs independently of what's sort of going on underneath. It includes an optimized version of Redhat Linux, so it knows sort of what the operating system is, as well as a whole bunch of security management, logging, and other capabilities to make it easy to manage and run the clusters. It makes it scalable and migratable. So this is sort of what the architecture looks like. You've got wherever you're running it. You can run it privately. You can run it in a private cloud. You can run it in a public cloud. On top of that platform, you put OpenShift, which has Kubernetes in it, and then on that you are running Cloud Pak for Data, which is the sort of centralized web-based all-in-one solution. And then you can add on containerized services to that, such as Netezza Performance Server. So this lets you run Netezza Performance Server in a variety of different places, including IBM's cloud, including AWS, and gives you a lot of flexibility. This is sort of the list of things that Cloud Pak for Data gives you, sort of in that all-in-one solution. And you can see there's some DB2 warehouse, PostgreSQL. There's some basic database capabilities in there. But as Nirav is going to talk about in a sec, Netezza is really a more sort of high-powered, dedicated solution for high-volume analytics. So often, if you have a lot of data, if you have existing Netezza installations, Netezza Performance Server is the better solution, and that is an extension to the basic Cloud Pak for Data. You install it into an OpenShift node, and it runs and takes care of your analytic needs. So I think we're now turning it over to Nirav to talk about a little more detail on what Netezza includes. But so just to keep in mind that you're running on this OpenShift platform that gives you a lot of flexibility. Nirav?
Thank you, Jeff. So before we get to NPS, I have a couple of slides to talk about Netezza. So some of the features, or rather most of the features that we'll talk of here will be available on the NPS or are available on the NPS. So what is Netezza, right? So it was one of the first data warehouse appliances, simple and designed for analytics ground up. So it's an integrated database, server, and storage. So none of this needs to be planned. It comes in a box. You deploy, put it in a data center, and start using it. It has overall low cost of ownership because once it's deployed, it's ready to use. You start using it, and then there is no tuning, no maintenance aspect ongoing or post-deploy. It delivers results immediately, right? So once it's ready to use, your analysts can start using and start deriving insights across a large scale or wide variety, large volume of data. And lastly, it has all standard interfaces to the best of breed analytics, BI or data integration tools. So any of the tools that you might be using today, whether IBM, non-IBM, you should be able to connect to this using the standard ODBC, JDBC connectors. So why Netezza? How is Netezza different, right? So it's the 4S, as we call it, speed. So it's 10 to 100x faster than traditional systems. So behind the scenes, it has an AMPP architecture. We'll touch upon that in the next slide. And that is the full MPP or fully parallel processing behind the scenes. And it offers optimized in-database analytics. So it runs your code close to the database where the data lives, and therefore it offers high performance. Simplicity, so minimal administration and tuning. So for people a lot of folks who like DBAs, we always know for performance, you need to manage indexes, create indexes, manage them. That's a big maintenance task, ongoing maintenance task. Netezza has no indexes. You don't need to create indexes. It just takes care of its own using its own maps. We'll touch about that in the next slide. There is no other tuning or knobs to be turned to be able to get best performance out of it. The next one is data model agnostic. I have it here because we get a lot of questions at times saying, would it work with a more star schema based model or with a third normal form or even the data vault, which is one of the newer modeling techniques these days. So from a Netezza perspective, as far as the data distribution across the nodes is done uniformly as much as possible, it will perform well, irrespective of the data model that you might have behind the scenes. Scalability, it can scale up to petabyte capacity, and performance generally scales linearly with it without any minor intervention or adjustments on our part. And then lastly, the fourth S is smart, high performance advanced analytics. So it comes with a lot of inbuilt analytic functions, 200 plus functions if we start using it, and that executes in database, delivering high performance once again. And it also provides connectivity to other big data platforms if you are within Hadoop or any of those other open source or big data platform components. So at a high level, the architecture, right? So it leverages the best components of the SMP and the MPP architecture. So as you see in this diagram, it has two hosts. So one is active, the other is passive. This is part of the overall HA and the total redundancy package. So what does the host do? So once a query is sent from any of these applications that you see here, whether it's a BI or ETL processing, they optimize, it generates an optimized plan. It then breaks down, compiles these queries and breaks it down into snippets, which are then sent to the MPP to be run in parallel. And once this parallel processing behind the scenes is done, it aggregates all of the data and responds back to return to the query results to the application. So on the left, as you see, it's pretty much shared nothing architecture behind the scenes for a node. So each node has its own resources, everything that it needs to perform in parallel. And there is one component here I want to talk about is FPGA, is Field Programmable Gate Array. So as part of the on-premises appliances, this is the hardware-based acceleration. So when a query is sent, what FPGA does is it decompresses the data, it projects only the fields that you asked for, and it filters out the data based on the where clause. So it's already doing all of this before the actual processor comes into play. So this means you're scanning much less data before it goes back for actual query processing. And this happens in parallel across all of these nodes. So that's how it achieves optimal performance behind the scenes as well. Completely redundant, so there is no single point of failure. For example, the data that you have on the disk, it's replicated across a couple of other disks. So if a disk happens to fail, it will repoint to the other disk that has the data and start using it. So there is no impact on the application or the usage of the data. So what are the key features, right? So data distribution, I touched upon this earlier. It's important in Netezza to distribute the data uniformly because Netezza is as fast as your slowest node. So if one of the nodes is really taking a long time to return the query, the other nodes, even if they're done, the host still has to wait to aggregate the data and return the results to you. So data distribution is a very important feature that needs to be considered as part of the overall design when you start using Netezza. But once that is done, it's really fast out of the box. External tables. So this allows you to, you can use this for importing and exporting data in and out of Netezza, or even for backups or for your overall database. So it loads and unloads data from a remote computer. So the schema lives in Netezza, but the data doesn't. And it uses pipes basically to move the data. And this can be extremely fast, and it can use speeds up to kind of 2 terabytes per hour for large data movements. Zone maps. So this is an automatic feature. There is nothing we need to do about this. So what zone maps do, there are certain zone mappable types of columns like strings and data type in the dates. So what it does is it maintains the minimum and maximum values or the distinct values and null values across each database extents. So when a query comes in, the optimizer now knows where not to look for. So it excludes those extents and thereby help reducing the I/O. So this is almost like opposite of index, right? The indexes help us tell the optimizer where to find the data, whereas zone maps tells the optimizer where not to find the data. And this helps improve the performance by reducing the I/O because it's scanning much fewer extents than it would otherwise. Multi-versioning and serialization. So Netezza offers the highest level of transaction isolation level, serializable. So behind the scenes, every transaction gets a unique transaction ID. And Netezza does soft deletes or soft updates. So by that I mean is when you say an update, for example, it marks the existing record for deletion and inserts a new record with the new updated values. Similarly for deletes. And so that means these old soft deletes or updates live in the system on the disk and they occupy space. But from a performance perspective or from front-end perspective, this ensures that there is no issues with dirty reads or phantom reads that we generally run into when multiple queries are trying to update a particular table or a particular field. So for that, behind the scenes, there's another process that is recommended, right? It's called GROO, which basically reclaims the space because the space is being used, and if you don't do that over a period of time, you're losing that space, and it reduces the user data capacity on the appliance. So that's one recommended process that needs to be run. Materialized views. Once again, this is from a performance perspective. So this is slightly different from the MVs that we generally relate to, for example, an Oracle system, Oracle database. So here it's mainly meant for vertical partitioning of the base table. So you pick a few columns which you are constantly using in your select or where clauses, and it creates a view, materialized view on that. So the next time when a query comes in, the optimizer is smart enough to understand that there is a materialized view built on these columns. It is going to use that versus the base table, thereby reducing scanning. And the last one is workload management. So GRA, SQB, and PQE, what do they mean? GRA is guaranteed resource allocation. So you could create different resource group for different functions. So for example, you could create a resource group for a function, for a finance group, and say allocate 60% of the resources to them. You could say 30% to the sales group, 5% to the admin team, and 5% to the rest. So this ensures that your groups get the resources they need based on their requirements. Next, the short query bias. So Netezza is intelligent and understands if a short query comes in, which it defines by default as anything that takes less than 2 seconds. It will push that query through without having to wait for some long executing queries. The last is prioritize queue execution. So you can define 4 levels of queues and then assign associated users with that. So those users will get a priority over the others based on the queue they have been assigned to. So NPS. So before we get to NPS, Jeff touched upon Cloud Pak for Data. So this is a high-level platform architecture for it. It's broken down into these 5 layers. So at the top is a services ecosystem, and that's where NPS comes in. So the way this works is you select the service, you click Access and Deploy it, and once it's deployed there, you could start using it. Data virtualization. So this allows you to query data across multiple sources without actually moving the data, which helps with a lot of performance. Platform interface, single user experience, or a GUI. So this helps build efficiency, and so your data governance, data management, analytics all are across under one GUI, so it's much easier to manage and a single point of view for all of the artifacts. Redhat OpenShift. So Jeff touched upon that earlier, the Kubernetes layer. This helps you with smart and efficient deployment using this enterprise container platform, which is Redshift OpenShift. And then last thing is cloud or the infrastructure layer, right? So this is where you could, as of now, NPS is available on IBM Cloud and AWS. So you can avoid a lock-in with a particular cloud vendor, right? Or you could have a multi-cloud approach based on the requirements. So this kind of helps you do that. So NPS. So 100% compatible with existing Netezza appliances. So if you're currently using Netezza, the appliances, and you are thinking of moving to the cloud, or you want a hybrid architecture between the cloud and on-prem, everything that runs on your appliance today will run on NPS. You can easily upgrade or migrate to the NPS. It's a lift and shift approach. It's a simple command engine migrate. People use Netezza and they constantly use that for backups and restores, or even back replicating the data across other appliances. So you can simply move a database from the Netezza appliance to NPS with this one single command. So it is currently supported on IBM Cloud and AWS. Other cloud vendors are being worked on for the future. So the other services that would be very useful to work with if you're already using some of the IBM services is if you're using data state for ETL, if you're using Cognos for BI reporting. So these are also services available on the Cloud Pak as with NPS. So you could just deploy these and start using this in conjunction with your NPS. So if you're migrating from on-prem, all of these could work together on NPS as well. Or if you're into machine learning and using these notebooks, these are some of them, not an exhaustive list, you could use them as well. So Netezza also comes with the NPS comes in Netezza Analytics, which offers a built-in extensive library of statistical and mathematical functions. So these kind of abstract the complexity, and these are executed at scale in Netezza. They are available for folks who have machine learning and AI use cases. It also supports in-database geospatial analytics if there is use case or if there is need for geospatial analysis. These functions are available there as well. Minimal administration tuning, same with the appliance. There's nothing much to do once you have it up and running. And it's 100% compatible with IBM Fluid Query. So IBM Fluid Query is basically used to query data across different data types of data stores. So you would have some data, say in Hadoop, something on-prem, some on remote server, something in the cloud. So IBM Fluid Query lets you query across all of them without actually moving the data. So NPS is 100% compatible with that. So this is a high-level comparison between NPS, Snowflake, and Redshift. They are the other two cloud warehouses. So in terms of maturity, Netezza has been there for 70+ years. So very stable, whereas Snowflake, Redshift have been a relatively newer entrants for 5+ years. Platforms, so we talked about NPS working a couple of cloud platforms. Snowflake works on all 3 at this point, AWS, Azure, and GCP. And Redshift is focused on AWS. It's only works on the AWS cloud. Integration, so all 3 work with, as I mentioned earlier, any tools which support JDBC or DBC connectivity. But for example, IBM, the NPS cloud if you're already on an IBM ecosystem, it integrates natively with these services, data state, Cosmos, and others. Similarly, Redshift is focused on the AWS ecosystem, all the services out there. And then Redshift, Snowflake, it has built partnership with a lot of other tools like Material and Tableau software. So they have native connectors for them. Architecture, Redshift and NPS both have storage and compute coupled. They are not totally decoupled as in Snowflake. So for example, in Redshift, when you want to start up a Redshift cluster, you need to define your node types, which kind of then decides the storage and compute. Scalability, all three being cloud, fast, elastic, reliable, they can scale almost infinitely. Ease of use, NPS, once it's deployed, it's ready to use, really start writing your queries and then deriving insights. Snowflake, simpler of all the three, it's a software as a service. You create an account and start ingesting your data and start using it. It's straightforward in Snowflake. Redshift, less simple. If you're not using the AWS other services, you're not already on the AWS ecosystem, it would mean for the Redshift cluster, you have to define your VPC for security. You have to create IAM roles and groups, and then also, more importantly, identify the node types based on your workloads. So there is some involvement before you get started on Redshift. In terms of data types, NPS and Redshift design only for structured data, whereas Snowflake supports unstructured data out of the box. Performance, we talked about performance on the NPS side. Similarly, Snowflake, Redshift are also MPPs, columnar DBs, they offer elastic scaling, resizing, concurrency scaling, and other features. In terms of data distribution, so NPS and Redshift, the performance is impacted by how the data is distributed. So it's important to have as much as possible unique distribution across all your data slices. Otherwise, data skew creeps in and that could impact performance. With Snowflake, you don't necessarily do that right off the bat. It really performs well, unless you run into very large tables, about a terabyte or so and more. So Snowflake, in this case, it's much easier to use. So all in all, NPS offers least disruptive path for migrating to the cloud if you're already using other IBM analytic tools. And then in summary, so users benefit from a hyper-converged, containerized microservices cloud-in-a-box architecture. This is mainly from the IBM Cloud Pak for Data. It's cloud platform agnostic. You can choose your cloud of choice. Highly performant and simple to use out of the box. It's once deployed, you're ready to use. It focuses on deriving insights and not on maintenance. Not much maintenance, no turning of the knobs. And it's 100% compatible with existing Netezza appliance. So this is very important because it helps you for your migration to the cloud with your journey to AI in the future, or you will also have a hybrid approach where you could continue to use your on-prem along with NPS on the cloud. It could work that way too. So in all, it offers you a seamless migration of your analytics to the cloud, and that's where NPS comes. With that, we'll open up a Q&A. So if you have any questions.
Sorry, I was muted. We do have questions. The first question is, we have a data lake in AWS. How does NPS work with S3?
Okay, great question. So yeah, so NPS, you can access any data lakes, whether you're using IBM Cloud Object Storage or S3. Basically, use the external tables that we talked of. That gives you good performance with that. And as I mentioned earlier, you can also use external tables for backup, restore. You can schedule them at your convenience too. So that's why external tables is a very good functionality that is offered by Netezza and NPS.
Thank you. Related question, can I use NPS itself for a data lake?
Oh, that's a great question. Yes. So you could, whether you're on IBM Cloud or AWS, you can certainly use NPS for your data lake. You still derive all the performances that we talked of using the inbuilt features. And really behind the scenes, it's still a data store. So NPS will perform well, yes, on a data lake.
Yeah, and I will point out that, I mean, we see a lot of people do this because a lot of people, for their data lakes are structured data. Purists will note that a data lake should handle unstructured data as well, and if you have a lot of PDFs or images or things like that, you're going to want to use something else for your data lake.
That's correct.
The next question we have is, what challenges exist moving from a Netezza appliance to NPS in the cloud?
That's a great question. So what we have seen with clients, for example, they have been using Netezza for ETL, or you could be using any, right? But when you're on-prem, you could, for example, you could be having some lookups, right? Which currently they are where your source is at this point on-prem. But when you move to the cloud, so that could cause, for example, an issue. So these are the kind of things you may want to check in terms of how your ETL process the designs are and what all your data sources are in terms of data gravity. But besides this, in terms of compatibility, the code base is the same between Netezza appliance and NPS. That's going to run as it was before you are not going to migrate. So it's more on an overall ETL and any other, even on the reporting side, for example, if you're using Cognos, you don't necessarily have to rebuild your models, right? You basically have to repoint. But overall, the design and the way your data sources are, that's the key consideration when you're migrating from on-prem to NPS in the cloud.
The next question we have is, I have Cognos. So if I move from Netezza to NPS, will I have to recreate Cognos framework manager models?
No, you will not, but it will need a repointing to your new, obviously the new URL or the endpoint. So not necessarily you do not have to rebuild your models once you have the Cognos service enabled on Cloud Pack for Data.
Okay. And the next question is, can you still schedule jobs using cron to run on Netezza?
On Netezza, I mean, or you mean, assuming
I assume on NPS, yeah. And I'm pretty sure the answer, I mean, the host running is the same host as before. So if you're scheduling them within that host, the answer is yes. And if you're scheduling in cron elsewhere, then it's just a question of connecting to the cloud instance to kick off the job. But within NPS, you've got the same host that you had on Netezza, so the answer would be yes.
Correct. Yeah, it's just the interface how you get to the host. Once it's on the host should be able to understand and execute the schedule or the trigger.
And yeah, so right, and we're getting some confirmation on that from IBM, but yes, that is the case. Next question is, can we run the Netezza appliance and NPS in parallel while the cloud migration is going on?
That's a great question as well. Yes, you can. So this is the best part of this. If you could run on-prem and NPS at the same time because the code base is the same. So this really helps you with your upgrade. You can do it at your own pace. It's not that you one or the other. You could have both, and you could actually continue to use both if your use case demands such, right? If your data is a lot of important data lives on your on-premises solution, they can still continue to stay there, and then you can have new data sources, cloud-based sources in your NPS, and then you can have both of them as part of a hybrid solution. The short answer is yes, you can.
Okay. Oh, and to clarify something, Netezza does have some support, does support JSON data types. So you can do JSON semi-structured data with Netezza. So apologize for saying otherwise earlier. Thanks everyone for attending, and just wanted to remind you that we're going to be back next week talking about the modern cloud analytic framework, both on Thursday at 10 a.m. but also Tuesday at 10 a.m. And then we've got, we're continuing on both those times, so which is a shift from our Take30 data advisors, which used to be on Wednesday. So thank you for joining us today, and hope we continue to see you over the summer.
Thank you everyone for joining.